Good afternoon, everybody. This is Puya from midas. Before we start this session, I want to ask you to use this panel and raise your hand to ensure that you can hear me, and then we can start. All right. Thank you so much for confirming that. Um, as I say, my name is Puya. With technical support of midas, and we mostly working on the midas civil and other software. And today is the third webinar of the series that we started, and we were talking about the box girder post tension in the past two webinars. I had my colleagues Arun and Nitil that they were talking about that how to prepare for a bid to win the RFPs, and also Nitil was talking about the design of post-tension box girder, designing the entire bridge superstructure with the piles, modeling the piles, modeling all this soil structure interaction, applying the dynamic forces, and completely analysis of the post-tension box girder, and also complete design of that. So I will go ahead and just touch base with what is past, and then we'll start talking about the load rating, and then you will see that how midas civil could be with you from the beginning to the end, and then how it can help you to save time and do the bridge design work quickly and more efficiently. If you guys have any questions, please use the panel and send me the text, and either I will answer those after the webinar, or going to email you the answers if we didn't get the chance to talk after the session. Okay, so here are the two webinars that I was talking about. The first one was how to prepare bid for winning the RFPs. So in this webinar, Aaron was talking about the process of this bidding, and what happens and what you need to do, what the design engineer needs to do to get the work or that job. So in that modeling, Aaron was showing that how we can use the wizards, how we can quickly model the entire structure, and saving a lot of time there. And then after that, how to optimize the post-tensioning tendons in a way to use lesser material for the optimized design, and also how to get use the midas civil software to prepare the report for you. So in this case also you can save a lot of times. So was just talking about that, how the first part before we getting a job, midas civil could be in your service. Later on in the second presentation or webinar, we're talking about the design of post-tension box girders. And then we're talking about this for different part of structure. Normally they're using a different software for modeling the superstructure, piles, pier, and then applying the dynamic analysis, applying the moving load or construction stage analysis. And this is a kind of wasting your time, and doesn't help you in a way to be, speed up the work. On the other hand, midas civil could be used for modeling all part of the structure, all part of the bridge, including the piles, abutments, and then you can also model the soil structure interaction. You can apply the dynamic analysis, seismic analysis. You can go through the constructability checks, and by using the construction stage analysis and all those. And then you see how with one model you can get all these done, and you see how much it's going to save your time. So you don't need to get the result from one software and then convert the format and then import it to another software, and then get some part of the design there, and then go to the next one, and then this iterative process. So it's a kind of saving your time. You need less manpower to get certain project done, and GUI or the graphical user interface of Midas Civil is very convenient to work with, and it's not, at the end of the day, it's not going to make you tired. So these are the something that happened in the first and the second webinar. Now I'm going to today I'm going to talk about the load rating of post-tension box girders. In this series, we actually focused on the post-tension box girders, but this is not the end of Midas Civil. So Midas Civil actually could be used for all type of bridges, from the conventional to very high ends. And we are going to, in this series of the webinars, we're going to show you capability of software in a certain type of bridges. So let me just quickly go to the next slides. On this slide, you see a brief list of our users which they are using Midas Civil for their projects. And you see certain DOTs like Oregon DOT, California DOT, and so more, and name of some of the big companies which they're using the software, and we are so happy having these cooperating with us. And let me go to the next slide showing you what we are going to do today. What I do today, I just create a model for you, a simple box girder model, which will be with 3 cells, and just creating the nodes and elements, and then applying the boundaries, applying the static load analysis, and then we define the pre-stressing tendons, and then after that we apply the live load using the H2LRFD code, and also we will define the permit vehicle to use in the load rating. So for the permit vehicle, I have a lot to talk about, but let's talk more about it when we are working on software. And then we get the load rating. We're going to define the reinforcement, longitudinal and shear reinforcement. We're going to define those load rating parameters, and also at the end we're performing the load rating, and at the end we're going to compare check the rating factors. And then you see how easy it's done in Midas Civil as compared to normal practices. So for certain type of bridges, you can use simple structure, simple software. You can just model them and get them, perform the load rating. But when it's come to the, let's say, post-tension type of structure, or different types which are more complex compared to the simple one or conventional, then you need to run the analysis, model the bridge somewhere with certain software, then get the result, and then use your spreadsheet doing this iterative method, let's say modeling a certain type of permit vehicle with a certain tonnage, and then getting the result, taking to the Excel, and then performing the load rating there with the spreadsheet that you created probably in your company or got it from the DOT. And then again, you have to do this iterative method to finally come up with the tonnage of the bridge or the capacity of that bridge. But in the Midas Civil, you don't need to do this iterative method. You just model a certain type of permit vehicle. It's very easy, very quick to do that, and there is no limitation on the shape of this permit vehicle. And then run the analysis quickly in a couple of seconds, and then you can check the results, and then simply you can find the capacity of your structure, your bridge, in a very, very short time. So today we'll see how it's done. Okay, so let's start. The load rating actually is simply defined as a capacity of a structure minus the permanent loads divided by the vehicle loads. So why we are doing the load rating? Actually, the load rating is done to get the capacity of the structure. We have an existing bridge, or we are going to design a new bridge, and now we are checking that if a certain type of vehicle with a certain weight is running through this bridge, is it safe or is going to fail? So this is what we are going to study today from the load rating. And then we have 2 types of load rating. One is the inventory rating, which is used for the design loads, and then other one is operating rating, which is used for the design load as well as for legal and permit loads. So today we model both standard vehicles, which are the vehicles which AASHTO recommends, and then we are going to model a permit vehicle, which normally each DOT has its own permit vehicle, so we can simply model without any limitations. So here is the process of load rating in Midas Civil. So we can simply model the bridge and then perform the analysis, and then next step will be defining the permit vehicle, which could be the user defined, or you can get it from the library, which we have certain permit vehicle for California DOT. And then defining the parameters of a rating is very simple and straightforward, and then performing the automated load rating. Midas Civil 2013 is capable of doing the rating as per AASHTO LRFT 2011, which is the latest version of the load rating by AASHTO. And then at the end, we are checking the rating factors, and then we're comparing that. We are seeing if the structure is safe for a certain type of vehicle or not. Okay, just let me quickly talk about the model that we are going to create. It's a very simple model. It's going to be a two-span post-tension box girder bridge with a 184 and 128.5 feet length of each span. And this is a cross-section. You see we have three sections, three cells. And we are going to post-tension and applying this post-tensioning tendon inside each web. Okay, so let me quickly open the Midas Civil. For whom are using the Midas Civil 2012 or they are not using Midas Civil, this is a actually new version of Midas Civil. It's called Civil 2013. This is a new GUI, and so you see how the GUI is easy to work with, how easy to find each icon that you are looking for the modeling, for applying load, for running the analysis, and how to get the result. I'm going to show you one by one. So this is actually done in a way that become more and more user-friendly, and you will see how it's going to help us today. Okay, just let me check the view. And sure. Okay, so let me quickly just explain about this GUI. This is the main part of the software, or we call it model view, where is the place that you can visually see where you are modeling. And then at the left side we have the tree menu, which has a tables, work, and group table, and also the report. So my colleague Nitil talked about how to use the report option to get the dynamic report generator and writing the reports in a way that you desire. Today we're mostly working with these two tabs: work tab, which has a list of whatever we are modeling, and then the groups. So at the top we have this ribbon menu, which if by clicking on each one we have several more options, but it's put in this way that it's very easy to find. So for a structure you can find the wizard, for notes and stuff, so more. What I need to do now, I just create create the notes and also creating the elements. So for that, just go to the node, create notes, 0, 0. Okay. So what I do today, just using the extrude option, element, create element, and then extrude option. So by extrude, I can just create the elements from the nodes. And I'm going to use this material and this section, unequal distances. And as you saw, we had two span. The first span was 184 feet. So I divide that span by 10 elements, so then we can get more accurate results. So I go with the 10 at 18.4 and 10 at 12.85, and selecting the element, the node, and apply. Okay. So you see how quickly we created this bridge, and this is the cross section. Actually, I imported the material and the cross section to save the time and talk more about the rating process. So you can simply just import the file from previous project that you got, or if you model it somewhere else. Okay. So here's my cross section, and now what we need to do, we have to apply the support, and also we have to model those tendon profile. Okay, so let's quickly model the supports. It's very easy. Going to the boundaries, support, and then for this end, I'm going to dx and ry, rx, selecting the node and apply. And then we got, if we go to the top view and turn on the node numbers and the element numbers. Okay, this is another one, and the one at the end, which I'm going to use dx dy and ry. Apply. Okay. Now we don't need the node number or element numbers, so we can turn them off. So the next part will be modeling the tendon profile. So modeling the tendon profile is very easy. What I do, I just go to the load, pre-stressing, tendon property, add, and call it tendon. So we have three parts, but now we're going to model it as a post tension, and then the material, we're selecting this material, tendon area, 40 half an inch diameter, or if I put it on the, I'll just switch the units to the inches, so I have a better feeling about them. So we can model the tendons, and then later on we can change them. That's not the limitation. Or it's too much, we can go with lesser number. So I can go with like a 30. Okay, and then duct diameter 5 using the CBFIP, which is a common practice for the relaxation losses. This ultimate strength 270, that's fine, 227, and curvature 0.2, and then wobbling going with the default. Okay. Then now load, pre-stressing load, and tendon profile. So you see how easy you'll see how easy it is to model the tendon profile, because in some software it's really hard and takes time to model the tendon profile. And today I'll see you how we can simply create the tendon profile. All right. So the first one, I call it tendon 1. As you saw in the first slide, we're going to have 1, 2, 3, 4 tendons on these webs. So I call the first one tendon 1 and it's going to be to the one in the right. Tendon property, selecting from the one we already selected. Assign element, so we can simply go to the top and select all the elements. So it's going to be from element 1 to 20. 3D and spline, okay. And then I can simply enter the values that I have. So you see, if you have the values in Excel, you can simply copy paste it here, but you can just enter one or two of them, then enter in the bringing in the rest of them from the Excel. So going to be, let me put it on the feet. Okay. Because the value I have here is based on feet, so it's easier to follow. Negative 15.5938, and then the Z, negative 0.1387. Okay, the second one. So to save the time, let me just copy paste them from Excel. So I just copy it and then paste it here. Oh. 3D. Alright, so here 3D splined, and then we're selecting the tendon and call it tendon 1. Assigned element will be 1 to 20. Everything is fine. And then for the insertion point, I select the element 1 for this. So it starts from the element 1. Element 1 is the first one on the left. And apply. Okay, so you see that these tendons are applied. And there is just one thing. I'm going to fix it later. But let me enter the rest of the tendons. I call it tendon 2, bringing in the coordinates. Delete and bring it here. You apply on the same elements and apply. Okay, tendon 3 will be the same thing, only the Y will be positive. So what I can do, I can just make them as a positive, 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 positive. Okay, so insertion point element 1, apply. Yes. Okay, and then we got the last tendon. Okay, so it's going to be tendon 4, deleting all these and entering the values. Okay, now we have 4 tendon profiles, and let's just check them. It's also possible to model one of the tendons and then copy the rest of them with the same distances. So let's go to the front view and check. See, here is the thing. We got this tendon profile correctly for these 2 webs in the middle, but for the side webs, because these are like angled, these one are not going through the right direction. Therefore, we have to change this. How to change that? Midas tool is actually giving you an option to rotate the tendon profile, and then it's possible to do it for the inclined webs. So how to do that? For the first one, we go with the 18.5 angle of rotation and apply. You see this one is fixed. And then we got the okay, we got the number 4, and then for this one will be negative 18.5. Yes, and okay. Alright, now if we double click on this, you will see that each one is placed in the right direction and in the right elements. Okay, so you see how easy it is to fix these. So this is unique to midas civil, and it can help a lot to save time, and then you model the accurate modeling. Alright, the next part will be modeling the static loads and self-weight. So for that one, we go to the load, static load cases, we define certain load. The first one will be self-weight, and then the type is a dead load, add. And another one will be dead load of the wearing surfaces. I can select it from here, DW, and add it. And then I can select the pre-stressing or post-tensioning, PS, pre-stressing, and add. Okay, so we have to assign these loads to the structure. The first one will be the self-weight, so going to the self-weight, and in a negative Y global direction, and add. So self-weight is applied to all this structure, all the elements. And next one will be element beam loads. So we're selecting the entire element, entire this structure by clicking on this option and going to the negative 0.1 in a global Z, and selecting the load case as a dead load wearing course, and apply. Okay. So if you have, let's say you have eccentricity here, let's say you want to model the barrier, and then they are placed on the both sides of this on the deck. So simply we can just use the eccentricity here and then place them, one of them on the left side, one of them on the right side. The reason that we are modeling this bridge as a spine model, so let me turn this off, and you see that this model is only a on display and on display. Okay, you see that this model is only one beam, and this is the way that AASHTO actually recommends. AASHTO says that for the box girder, post-tension box girder, we can model them as a spine model, which means you are using modeling entire the bridge as a single beam, and then you are just giving the sectional property of that beam to this structure, and then we can perform the analysis. But this one is not actually that accurate if you have a wide multi-cell girders. At that point, you need to model the bridge as a grillage model. And midas civil made it so easy, so you can simply, instead of like creating the nodes and element and then go through defining all those, so you can simply use one of the wizards, which we call the grillage model. You can see it here. So you can simply define the material section, and all the span and all those, everything will be modeled. It probably takes like a 5 to 10 minutes to completely enter everything, and then by one click you're gonna have that. You can also save that model for future references. Later on you can just open it and then do any changes if you want. Okay, but today we're just modeling this because here we have only three cells, and for this model it should be fine. So we are following the AASHTO recommendation. Okay. All right, so you saw how we can model if we have eccentricity or we have only one beam, but we want to apply the loads in a different location. Okay, this one is done. the next part will be modeling the pre-stressing forces. So for that one, so we actually created the defined the tendon profile, tendon property. We modeled the tendon profiles, and now we need just to apply the forces, pre-stressing or post-tensioning forces. So going here, select all the tendons, add to the selected list, and then from both ends we are going to post-tension them by 189 KSI. Oh, this is KSF. We have to change it to KSI. 189 and 189. Okay, so for the pre-stressing or post-tensioning, you can both enter the values as a forces or stress. This is in your hand, but here we have the stress. Okay, add, and it's done. Okay, so we model the structure, self-weight, pre-stressing forces, everything is modeled. So let me just model the moving load, because here, as I mentioned, we're going to talk about the permit vehicle and also how to model the standard vehicles. So let's do this. Load, moving load, and also you see I'm finding the my icons here, but simply you can just use these options on the top, this menu, and find them there. Is like a more visual, and for the beginners that's probably better practice. Okay, so we can select one of the codes. Now we are going to model based on the H2LRFD. So I select the code and okay. Now see if I go to the loads, we have the moving loads here. So the step will be defining a traffic line lane. I'm going to model two lanes, one on the left, one on the right. So it will be lane 1 here in inches. So anytime that you need to change the units, you can simply change that. It's not going to affect the structure, I mean your model, or misplace any boundaries or any element or any loads. So completely safe. Add, I call it lane 1. And backward and forward, I give the eccentricity of 10 feet, and selecting two nodes, the first node and the last node. Because go to the top view, I have better view here, from here to here, and apply. Okay, this is lane 1, and the lane 2, the eccentricity will be -1 with respect to the line, the reference line which I selected, which is the right in the middle of the bridge. Delete. Again, selecting from here to here, and okay. All right, now we got two lanes, which are in the place in the both sides of these boxes, and now we need to define the vehicle. Okay, let's see what we got for the vehicles. You see here we have add standard, and also we have add user defined. We're going to use both of them. First, we are using the add standard to get the standard vehicles based on the H2 LRFD. So here you can select based on the H2 LRFD or H2 standards or any other one, but now we're going to follow LRFD. Okay, the first one will be truck, dynamic load allowance 33%, and okay. Let's define a tandem also, 33%, and okay. All right, now let's go to the user define. For the user define, you can define a truck as a user define. You see you can just enter the axle forces here, axle loads, and the distance between the first and each two axles, and then the software automatically divides them into the wheel loads. And you can also define the distributed load, or if you have any point load anywhere based on the code that you are following, you can simply model them here. But this is not what we are going to use. We are going to use the permit truck. Okay. Let me talk a little bit about this permit truck before we go ahead and model it. So we have to model actually a vehicle, okay, which is a standard vehicle. We can model it based on the H2LRFD, Caltrans, H2 standards, or any other codes, and now we can model it also based on the Canadian code. The latest version of Canadian code is S6 2010. And here is the way we are going to model the permit vehicle, okay? This example is an example from Caltrans, which this is just a truck that they didn't need to run on the bridge. So we can model all these, regular or irregular shapes, symmetry or asymmetric axles and wheels. So as you see here, we can just simply do that. We are defining the loads for axles and the wheels separately, and then we can just get the combination. So technically, based on this model that we have available on Midas Civil, you have no limitation on modeling the permit trucks for the running on the bridge. And I'll show you in the next step that you can get the combination of these two, combination of permit vehicle and then the standards vehicles at the same time. And because sometimes you need to model a small vehicle, is not like a really huge vehicle, and then you need to get the combination of those with the standard vehicles. So that made it so easy. Any shape of structure vehicle you can model, and then you can get the combination of standard and the user defined. Okay, so let me just quickly model one part, and then I will use that standard vehicle which is predefined in our library. These are some of the permit vehicles, so we can select each of those and then it's gonna show up. We call it permit vehicle 1, and then you can apply the impact factor. Let's say call the axle 1. Here the first thing is I'm defining the axle 1. It could be symmetric or asymmetric. Just entering the force 1 as a 40 kips, and then the distance 1 will be 5 feet. So this will be my first axle. So if you look at this diagram here, you see that you can have like unlimited axles, and you see that spacing between the wheels could vary. For example, this one, axle 2, has smaller spaces compared to the axle 3. So it's not like all of them should follow the same pattern. Or the distances between axle 1 and axle 2 could also vary. And if you don't select the symmetric, then you can apply a different forces on a wheel 1 and wheel 2. So that's all depends on what you're going to model. So let's model this one. So it will be axle 1, then I get the axle 2, let's say 30 and 5, and then 30 and 25 or 50. Okay, and then add it here, and then you can simply modify them or delete them. And then here you can, whatever you model there, it shows up here. You can select the spacing between this axle and this next one. And if you have a varying spacing, you can simply model it here. Here we have only 2 vehicles, so it doesn't let me to check it. Oh, okay. Now we can get this, and then let's say spacing is from 20 to 50 feet. Okay, so that's the way that you are modeling. But please let me open as a user-defined permit truck, and I'm going to just use one of the predefined vehicles, P15. Okay, so you see everything is modeled here. This is one of the Caltrans vehicles which we define. Okay, and we call it as a Caltrans permit vehicle. Okay. Okay. Now we define the lane, we define the vehicles, and now we have to apply these loads on top of the bridge. For that one, you can just go to the load combination, click here, add. we call it tandem add. See, the one that all of them will show up here, the permit vehicle and also the standard vehicle. So I select the tandem. I just apply this one on both of the lanes. So minimum will be 1, maximum will be 2. We are selecting both of the lanes. Okay. And then I select, let's say, apply. And then I select truck. And this time I delete this and adding a new one, which will be the truck. Again, applying on both of the lanes. Okay. And apply. And then we can just model, we can model the permit vehicle from here, just add and simply as what we did, just select it here, or you can just go ahead and do it here. Load rating for the permit vehicle. So the only thing it shows up will be the permit vehicle. Reference line will be 1. Eccentricity, we can get like a 10 feet from the lane 1, or no, we can go 0. Okay, because it will be on top of the lane 1. That's fine. And okay. So permit vehicle. Okay, so we got 3 vehicles and they are assigned to the structure. Okay, so now we're done with the modeling of this part. Now our structure is ready to perform analysis. But before we move on and performing the analysis, I want to prepare the structure for load rating. So for that one, first I want to assign the different elements into the different groups. Then I can just put them, assign a different span on them. Yeah. So let's go to the top view and then structure, PSC bridge. Now we can define the spans. So I call the span 1. I select the elements that I want to be in the span 1. So you see, let me just turn on this support. Then you see where are our spans. Okay. So the left one we'll call span 1. I want to select them. First I have to unselect everything. Now selecting this left side and add and OK. Alright, and I call the span 2. I have to unselect everything and then select the right hand side elements. Add, and close. Okay. Now we're done with the spans. Now the next part will be defining the reinforcement. So when we're performing the load rating or when we're going to design, definitely we need to have the information for the reinforcement, for the shear reinforcement and also longitudinal reinforcement. For the analysis, it does not matter because it doesn't participate in the section stiffness, therefore it's not included there. But later on for the design, definitely we need to check that. So going to the section and reinforcement, going to the reinforcement, and simply you can just model the reinforcement here. Okay. See, I got the reinforcement 1, left side and the right side. We should call it the span 1 and span 2. You see that the girder names are showing up here. Let's say selecting the span 1. Okay. Now start point will be from support 1, which is the one all the way in the left. Diameter, let's use it 8. Number of them 20. Reference, okay. And then Z will be 0.3. And then spacing 0.5. Or we can go with the 0.5 foot is fine. And then for the endpoint, we go with the halfway of span and add it. So this will be for the first part. And then for the second half of the span 1, I select the span, middle span will be the reference point, just changing the number. Let's say we are using a 30 rebars, and then will be span 2, support 2 will be the endpoint at. Okay, simply we are just doing the same thing for the span 2, support 1, and then span 1. Diameter, we are using the same size. Number will be 30 this time because this will be right here beside this. 0.2 and 0.5. Span 1, that's correct. Apply. And the next one will be the middle span to the support 2, and we are just changing numbers to 2 of them, to 20 of them, okay? And add. So simply later on, if you want to change these, you can come back here and do the changes. On the, this diagram, you can see the arrangement of these bars. So let's say I want to change this to the 1 or 1.2 feet, and then modify. You see that we have the wider span. So let's just put them 1.2, and then we spread all these. Okay. So you can see the reinforcement right here of the sections. Okay, let's move on, and then what else I need to do before running the analysis is just to let me define the groups. So for the group, I just define 2 groups: structural group called span 1 and span 2. Okay, and then from the work, I select the span 1 group and then drag and drop it here, and the work, double click on span 2, and then drag and drop it here. So 10 elements are assigned to either one. Okay, so now we are fine to perform the analysis. Let's just run it, and just hit the run. And we're having eyes on the message window, because if there's any error or warning in the modeling, it's gonna show up. But everything went fine. There's no problem here. Now we're done with the performing analysis. So now you can just simply go ahead and check the result. For example, you can just change the bending moment stuff. But this is not what we're going to study today, because these were things that we talked earlier. In the last time. Okay. So what I'm going to do, go into the design and then load rating. Give me 1 second, please. All right. So what I need to do, go into the design part. As you may know, Midas Civil is performing the PSC design as per H2LRFT 2012, and for the load rating goes with the latest version H2LRFT 2011, and I'm selecting 2012. Actually, this is 2011, but it will be fixed. Now, here on the load rating, we need to define the code, which we already selected, H2LRFT 2012, and then define the rating cases. Okay, here's the thing that we can define based on the code requirement. For the dead load, we have to select the self weight, and then we're giving the maximum. Okay, we go with the strength limit first. Yeah, and I define self weight, and you see automatically is applied 1.25 for the maximum dead load, and then a 0.9 for the minimum. So if you want to change that, simply we can change it to 1, and this one also to 1. And then for the dead load of a varying course, I gotta select the static load that I defined. And we have a secondary effect. Secondary effect will be, the only thing we have here will be post tension. Yeah, for the load rating, we are using the post tension secondary effect with the factor 1. And then for the primary vehicle, Primary vehicle will be the permit vehicle. We are giving the factor of 1. We can give the 1.75, and then for the adjacent thing we can go with the truck and 1.5, 1.1. Okay, and the name I call it as a strength and add. Same thing we do with the service limit state. So you see everything remains the same, nothing changes, but everything would go with the factor 1. So we are not changing that one. The only thing I'm going to change here will be for the permit vehicle, I'll go with the 1.15, and then the adjacent I go with the 1 and add. So I gotta change the name to the service and add. Okay, this is done. Next step, rating cases we defined. Rating parameters. So for rating parameters, we have the flexural, shear. We are going with the segmental, no segmental is not segmental, and stresses. I'm going to limit the compressive strength of the concrete as a 3.5. Actually, it's a keep feet. So I'm going to the keep inch, and I'm giving the 3.5 for the compressive and the tensile 1, and then for the tensile strength of the pre-stressing tendon, I go with the 30 KSI. Okay. Then rating group. These are the two groups that we define, span 1 and span 2. So what happens here, by defining these, we are performing the load rating on these elements. Let's say you have a big structure and you don't want to perform the load rating on all part of the structure. So you can simply select, assign certain part of the structure. Let's say this part, you want to check it for the shear. You can select these 3 elements, assign it to the certain group, and then you're going to have the groups here. Add and close. So now, based on this selection, it actually runs this load rating on all these elements that we have here. Okay, so now we are ready to perform the load rating. You see how easy it was to actually set it up. If you want to, before I perform the load rating, let me just quickly do one more thing. Let's say you want to check the losses. Okay, so based on that, with this software, you can check the approximate tendon losses. Okay, let me show you how you can say that. You can select the code here. Let's say I show FT06, and then selecting the humidity based on 70% and compressive strength of 3.5 KSI, and okay, then here we are adding the self weight here, and then the wearing course up there. Okay, yes, and so now if we run the analysis, we get actually the approximate tendon losses based on the ASHTO code, and this is a good check for you. If you define the construction stages also, you can just get the tendon losses in the different stages, different days. But this is not what we're going to talk about. Okay, we've done this. Going to the design, load rating, and rating design. So I got another model file which already will perform this load rating. I can just open that one and check the results because we are running out of time. Okay, so this is exactly the same model. We run the load rating, going to the design, and now we're going to check the results. Okay, so for the load rating, see what you can check. The first, let's check the services. Okay, just click on that, select the service load that we defined, and okay. So it's going to see it's giving you certain factors. You can check them all here for all the loads that we defined, and then the factors that is applied on them based on for the serviceability. If it's actually in the red, it means it's not good, and the factor is going below what we are expecting. and if it's in a black, it means they are safe and they are fine. So this was for the service. Let me quickly show you the rest of them. We can go with the check the strength also. Okay, for the strength, it checked, and it's fine because we are in the black, and then you can see all the factors and all the forces that adjacent for. I mean the forces that these factors are multiplied to. Okay, let's see what else you can get from this. You can get the concrete stresses, and you can select the number of elements and also the parts that you want to check. You want to check for the pre-stress and post-tension. For compression and tension. And here are the things. And as you see, for the different elements, it just gives you the different loads for the for this. So, for example, if you want to check certain element, you can simply come here and check them if they are fine for the compression and tension both, or they are not good. So by mentioning that not good, it means that they are not okay, and if they are good, so they are okay. So it means probably the forces that we applied here, that permit vehicle force, is too much for this structure, for this bridge. Okay, so because all of them are going to the red, that means this bridge doesn't have that much of capacity. Okay, so you can get also the flexural stresses. So now here you see on the different span, you can sort them, simply sort these dialogues based on the what you want, based on this heading that you got here. You can simply copy paste them into Excel, and for example, here for the strength limits, they are fine. For the service limits also, you can check the other option. Okay, here is the thing. You see that using midas civil for load rating make it so easy. Now you got your model. You created your model. You can perform any type of analysis that you want on top of bridge. Let's say you have moving load, you have construction stages, you have seismic loads. You can perform all those loads. Okay, get the result. Bending moments, shear forces, deflection, anything that you need for your design. You can perform the design. Simply run the design, or running the critical section, or you want to run for the this and that section. You can simply select them and run the design. And also you can define your permit vehicle. You can perform the load rating on top of this bridge, and complete the result. And also at the end, you can get the report. So the dynamic report generator generation can completely create a report for you for all parts, from the modeling, from the section property, material property, geometry, everything that you want. And also the results, you checking the bending moments. Simply you can just use the software to import it into the report generator without any hassle. You don't need to copy paste anything. You don't need to take a snapshot. It's automatically done. And if you change anything, it's going to also help, change in the report as well. So yeah, that's the part of the structure, part of the midas civil, that you can perform the load rating. And let me see what else I can show you here. That's pretty much it for the performing the load rating. Yeah, so if you want, you see that these are the other type of result that you can get. You can also get them in the diagram, but we don't have much time here to explain all these. But please send me your questions, and if you want to know more about this capability for the load rating, please just give me a call. Actually, we had a lot to talk here, but because of the time, I cannot go through all of those. Okay, so here's the thing also for the moving load analysis. Doesn't matter how many wheels you are defining or how many axles you are defining. Midas actually performs the influence lines based on for all of those axles and all the wheels actually. So you get a pretty accurate result. It doesn't go with the assumption or summary of those things. So okay, I think I'm gonna finish this webinar because we out of time. And here is my contact information. I hope you guys enjoyed the webinar, and send me your questions, or give me a call, and then we can discuss more in detail about this one. Thank you for attending this webinar, and you have a great day.